What's up, people? How's it going? Welcome back to CP with Sundar. So, in this video, we'll be discussing the solutions for some interesting problems from CodeChef Starter 116. Now, before moving on to the solutions, I lately noticed that most of the viewers of this channel are not subscribed to it. So, I request you to take a moment and subscribe to the channel so that it will be motivating for people like me to make editorials and videos on CP in the future. So, with that, thanks for the consideration. Now, let's start with discussing solutions to the problem.
Now in this video, let's discuss how to solve the problem permutation sort. So I found this problem a bit interesting in starters 116, and in division 2 it has only been solved by 20 people. So let's discuss how intriguing this problem is and how we can solve it easily. So in this problem, basically we'll be given a permutation of length n, and we have to select few indices, right? So we can select in any order, so it not be in any ascending order or descending order, and the number of indices that we select should be an even number. And after selecting it, we can swap the elements which are present at those indices. So we have to check whether we can sort the entire permutation in at most log n to the base 2 number of operations, right? So how to solve this? So basically, whenever we have a problem which involves sorting of permutations, we should be thinking in the direction of forming cycles. So if you want to sort any permutation of n elements, then the sorted array will be having all the numbers right from 1 to n in ascending order. Right, so the sorted order will be something like this. So it will be having all the numbers from 1 to 8 listed in the ascending order. Now, what do we mean by cycles? So let's look at the first index. So first index is having a value of 2, but we know that 2 should be present in the index 2. So for permutations in the sorted order, all the elements will be present at their own indices. That is, 3 will be present at the index 3, 5 will be present at the index 5, and so on. So if you want to place 2, 2 should be present at the index 2 in the sorted order. So 2 should have been present here, and 3 should be present in the index of 3, and 4 should be present in the index of 4, and 6 should be present in the index of 6, and 5 should be present in the index of 5, and 7 should be present in the index of 7, and 8 will be present in the index of 1, and at last 1 will be present in the index of 1. Right? So this is what I mean by cycle. So we are starting and ending at the same place. So we can have multiple cycles for the same entire array, and in this case we are just having one cycle. So I'll just write the cycle over here. So what are the distinct elements over here? So we have got all the 8 elements over here, right? The thing is, in this problem we just need to find few pairs which we can swap, right? So if you see, the element that is present in the first index should be swapped with the element that is present in the second index. That is, the element which is present in the first index is 2, but 2 should be swapped with the second index. That's what it means. So 1 should be swapped with 2, 2 should be swapped with 3, 3 should be swapped with 4, and so on. So if you take 5, so 5th index should be swapped with 7th index. So if you see 5th index, what is present in 5th index? So it's 7. So this particular element should be swapped with 7th index. So that's what it means. So we have to perform all these swaps, right? Now let's try to form the pairs such that the number of swaps are the maximum. So we can do 1 and 2 swaps in the first operation, along with 3 and 4, 6 and 5, and then 7 and 8. So in the first operation, we can do 4 different swaps, right? So if we do these swaps, then the array will be transformed into this. Now if you see, 4 elements will be automatically placed in their sorted positions. So 2 is sorted now, 4 is actually present in the 4th index, 5 is also present at the 5th index, and 8 is present at the 8th index. So these 4 elements are sorted. Now with this as the base array, let's start finding out the cycles. So if we find out the cycles for this, then we are starting with the first index, and first index has the element as 3, so we should be going to the third index. So third index has 6 as the element. So if you go to the 6, then we find 7. So from 7 we have to go to 1. So we have formed a cycle over here, and it has 4 distinct elements. Now what are the different swappings that we can do? So we can do 1-3 swapping, and we can do 6-7 swapping. right? So if you do these two swappings, then the array will be transformed into this. So over here, all the elements except for 6 and 1 are sorted, right? Now with this, we'll be trying to find out the cycles for the third operation. So what are the cycles? So we'll be starting with 1, and then the 6 is present at the index of 1, so we'll be going to the 6th index, and in 6th index we can find out 1, so we'll be forming a cycle. So we'll be stopping the cycle, right? So this thing's indexes are 1 and 6, so we'll be swapping 1 and then 6. So if you swap 1 and then 6 in this modified array, then all the elements will be going to their appropriate positions. That is, the array will be sorted. So what I'm trying to say is, in these type of problems, always find the cycles. Now in this case, if you see, we are just finding all the cycles, and we are taking the adjacent elements and swapping them. Now the thing is, we cannot swap 1, 2 and then 2, 3 in the same operation, but they can be done in different operations, right? So the ultimate goal is find out the cycle and then take the adjacent element as pass and then swap them. Now in this way, if we do, in log n number of steps, all the elements will be sorted. Now what is the proof for log n elements? So if you see over here, the n value was equals to 8, and in the first operation we swapped 4 pass, right? So which is nothing but it's n by 2, right? So it's guaranteed that when we have a search space of n elements, n by 2 number of elements will be sorted in one operation. Now in the second array, if you see, in the modified array, only there are 4 elements which are yet to be sorted. Now among them, we are selecting 2 pass, so 2 elements are sorted. So in the search space of 4 elements, right? So we had 8 elements in total, but only 4 elements are yet to be sorted. Among them, we'll be selecting 2 pass, which is n by 2 number of elements. Now when the search space was 4, we had only 2 elements which are yet to be sorted. Now in the last go, we had only 2 elements which are yet to be sorted, and we were selecting n by 2 number of pairs, which is 1. Now if you just look at the elements which you are sorting for each and every pair, so it's going from n by 2 to n by 4 to n by 8, so on till n by some 2 power k. So when will we stop this divisions? So we'll be stopping when this n by 2 power k is equals to 1. That is, the number of elements left to be sorted is just 1, or it's just 0. So this n will be nothing but it will be 2 power k. So if you find out the value of k, then it will be log n to the base 2. So that's how we can prove that we can sort the entire array in log n number of steps. So I like this proof a lot because it's very intuitive to solve. And we'll be applying ceil over here because we can go till the ceil number of operations. Now let's see how we can implement this. Right. So at first I'll be taking the inputs. I'll be running an infinite loop inside which I'll be trying to find out the cycles. So I'll be keeping a vector called visited, which it says like if visited of I is equals to 1, then it means that that particular element has already been found in some of the cycles, right? So if the visited of I is equals to 1, then I'll be continuing to the next element. Otherwise, I'll be finding out all the cycles, right? So the logic of cycles is that I'm starting from the element I and I'm going to the element v of I minus 1. So in this case, if you see, we are starting from the element 2, right? So the index is 1 and the element which is found in that particular index is v of I. So as I'm using zero-based indexing, so the 2 position will be v of I minus 1. So I'm just looping over all the elements and I'm just going to the v of 2 minus 1. And I'll be appending all the elements into the cycle, right? Now, for each and every cycle, I'll be just taking adjacent pairs. So I'll be skipping 2 positions over here, and then I'll be taking the adjacent pairs. So in this case, if you see, the adjacent pairs will be 1, 2, 3, 4, and so on. So I'm taking these 2 indices, that is cycle of I and cycle of I plus 1, and I'm swapping those 2 positions. And also, I'm just pushing back their indices into the swaps, so that these positions can be appended into the same operation. So this will be done till all the elements of the array are visited. So we can be finding multiple cycles in the same array, right? All the cycles combinedly will be claimed as one of the operations. So I'll be checking whether the swaps is empty. So if the swap is empty, then we won't be finding any elements to swap, which means that all the elements are sorted. Otherwise, I'll be just pushing the swaps. There is a indices for the operation into the answer array. So that's it. So I'll just print the answer to the console. So this is how we can solve this problem. So the main goal is to find the cycles and swap adjacent elements of the cycle as pairs. So this is how we can solve this problem. So that's all about it for today, guys. I really hope that you enjoyed watching this video and you learned how to solve the problem. And with that being said, if you haven't subscribed to this channel, please do consider subscribing so that it will be motivating for me to do a lot of videos in the future. In addition to that, I have recently started a series of videos where I discuss about segment trees in detail. So if you're interested in segment trees or want to learn segment trees, then you may consider watching this playlist. So with that being said, it's me Sundar signing off for the day, and goodbye. Have a nice day.